Securing Maritime Domain Awareness, or MDA, requires the 24/7 all-weather detection of impactful changes throughout a littoral area. Hello, I'm Ken Hersey from AnTrust, and today we'll be describing Pactal, our innovative technology, which enables MDA through the synergy of data from a variety of surveillance platforms which travel in random and arbitrary flight paths, unpredictable to an adversary. First, allow us to take a moment to describe our core capabilities. AnTrust is a small business aerospace contractor located in Columbia, Maryland, and was established in 2019. Our two overarching themes are RF comms, in which we've delivered multiple spaceflight antennas and RF components, and RF sensing, in which we've developed multiple novel algorithms using SAR, or synthetic aperture radar data. In addition to our engineering services and first article manufacturing and products, we also offer fabrication and test services, which leverage our machine shop, clean room, and our wideband 1 to 40 GHz anechoic chamber for the testing of antennas. Please see our website at antrust.us for more details about these commercial services. Turning back to the topic at hand, one of the most common analytical data products from SAR measurements is change detection. In general, this analytic identifies what has changed in the scene. For example, what has left in the target scene and what is new. For Navy applications, MDA can be secured by a recurring sequence of littoral SAR measurements which are applied to change detection algorithms, but current change detection techniques require that the same platform repeat the same flight path to detect changes. While this may be acceptable in a benign environment, performing surveillance using predictable flight paths can be lethal to the warfighter and air vehicle in a contested environment. Our innovation, Pactal, or Platform-Agnostic Change Detection for Littoral Environments, delivers actionable MDA warnings by detecting impactful changes in a target scene using SAR data from sensing platforms, using random and arbitrary flight paths. Enabling analysis using non-repeating flight paths significantly reduces the lethality risk to the warfighter and air vehicle, and yields a quicker time to decision and to action by engaging a wider suite of sensing platforms. SAR also has the benefit of RF visibility, regardless of time of day or weather. AnTrust is targeting 3 separate transition paths. 1. A SaaS offering through AnTrust or their partners. 2. A turnkey, AnTrust-produced SUAS platform with integrated SAR sensing. And 3. A software and/or hardware implementation licensed to prime contractors or their radar manufacturers to enable real-time SAR sensing and Pactal processing at the edge. As opposed to current change detection techniques, the Navy required Pactal to ingest SAR data from a wide variety of sensing platforms, including SUAS, UAS, manned, and spaceborne. While the flight paths of each platform are recorded, they are not constrained in any predictable manner. This increases protection from an adversary's counteractions. Pactal automatically screens the results to determine actionable changes in the littoral environment, while mitigating many real-world errors, such as motion compensation and georegistration, while engaging in environments where GPS signals may be unreliable, spoofed, or denied. The baseline operational usage for Pactal technology is to permit a wide variety of SAR platforms to overfly the threat environment, capturing SAR data for Pactal to produce incremental or aggregate results of impactful changes. One could envision the scenario of a commercial SAR satellite performing the initial overfly of an area of interest, which is later followed up by measurements from an F-18, F-35, and then a drone or SUAS, each on their own flight path, to determine any new threats. This enormous flexibility in using any SAR platform for surveillance increases the effective usage of manpower and platform resources. Additional Pactal embodiments could provide guidance and control for robotic systems in hazardous or weather-impacted environments, or could provide 24/7 all-weather automated improvements to border protection, drug traffic monitoring, and the surveillance of secure perimeters. As we've outlined, current change detection methods require either that the same SAR platform repeat the same flight path, or would require significant resource time for analysts to manually screen and determine changes from visible images. The improvement that Pactal delivers is an automated threat evaluation of the target scene, regardless of weather conditions, and regardless of the platform and its flight path. By being platform agnostic, Pactal can surveil the target scene more often given the increased availability of suitable platforms, improving surveillance update times. In addition, Pactal-powered products could be deployed at the edge, reducing the amount of data to be transmitted back to decision makers, and reducing analysis time to implement an action. Over the next few slides, let's do a deep dive to further understand the flexibility of the Pactal technology developed by AnTrust's. We've hinted at some of these capabilities already, but let's be specific. By any platform, that means we can use data at a different frequency band, at a different pixel resolution, at different grazing angles, and potentially different classifications, in addition to any flight angle when determining changes impactful to securing maritime domain awareness. In addition, we have specifically optimized the current embodiment to produce targeted results for the Navy's MDA of littoral environments, to highlight the impactful changes relevant to the threat environment being monitored. Additional embodiments could be re-optimized for other sponsors' applications. Let's look at an example of using Pactal. The area of interest, or AOI, is Sanya in the Hainan province of China. To the right, we display the reference capture performed from the east of the AOI. To the left, we display data captures at different times, each from a different angle west of the AOI, and at different grazing angles. While this is one specific example easy to illustrate, we note that the Pactal algorithm can accept data from any azimuth angle, and grazing angles are only limited to what would generate a reasonable single SAR image. Pactal performs its processing on each of the 3 data captures with respect to the reference capture, and displays the results in a red fled, blue new format. Thus, any vessel which has left the AOI since the reference capture is colored in red. Any new vessel entering the AOI since the reference capture is colored in blue. Moored vessels and those underway are identified in addition to very small vessels. In addition to the red fled, blue new format, we can also identify the results in an itemized format, for example, quantifying the results based upon specific locations and/or size. Phase 2 development of Pactal started in March of 2024, and we are currently maturing the algorithm through validation with measured data. We plan to conduct a controlled experiment in the summer of 2025 involving both spaceborne and airborne platforms, in addition to capturing data at different frequency bands and resolutions to stress test the Pactal algorithm. We are targeting the 4th Fleet Limited Objective experiment in the fall of 2025, followed by an operational test during the option period. Here we call out the key features, advantages, and benefits of Pactal to provide maritime domain awareness. First, platform agnostic. Pactal accepts data from a wide range of SAR systems, aircraft platforms, and satellites. This agnostic behavior significantly increases the amount of data that can be applied to an area under surveillance. Second, change detection is our key mandate, and Pactal delivers precise 24/7 all-weather detections of actionable changes, significantly reducing any human analyst time and reducing the time to implement an action. Third, we highlight that Pactal has been specifically optimized for littoral environments to ensure only relevant and impactful changes are flagged. Finally, Pactal reduces lethality risk to both the warfighter and air vehicle, since the SAR platforms do not need to fly along repeating paths, as current algorithms require. We've performed a market analysis for our technology and have identified transition paths for the Pactal-based products. Our initial transition path will create a software-as-a-service or SaaS offering, which will be available to customers via an existing GWAC or directly from a commercial analytics portal. In addition to MDA applications, AnTrust will also investigate commercial embodiments, for example, improving agricultural maintenance schedules and increasing first responder visibility and evaluation of disaster areas. The 24/7 all-weather capabilities can also improve Border Patrol surveillance capabilities. AnTrust will also develop its own market path, incorporating Pactal technology into a turnkey SUAS surveillance product available for general sales. Finally, AnTrust looks to partner with prime contractors and their radar hardware manufacturers to license the Pactal technology as a software add-on to their systems, or to develop an embedded processing card to provide these capabilities at the edge. We appreciate your time to learn more about Pactal and how it can benefit maritime domain awareness, in addition to the other embodiments we noted today. We look forward to working with you to see how Pactal-powered products can meet your requirements and objectives. Please visit our website to learn more about AnTrust and contact us via email for more information. Thank you.